Okay, so this is the other part of the day 2 notes. This is dealing with fractional exponents. So I want to show you two different ways of writing the same thing. If I put the square root of 9 in my calculator, I get 3. We know that. But I want to show you a different way of doing this. So 9 to the, remember I used this little, this little caret key right here when I want to raise something, to the alpha y equals gives me a fraction, to the 1/2, I get the same thing. And same thing, if I do the square root of 25, I get 5. But when I do 25 to the 1/2, I also get 25. So it is the same answer. It's just a different way of writing the same thing. So I can either call this the square root of 9 or 9 to the 1/2, square root of 25 or 25 to the 1/2. So if I want to rewrite things, this out here is going in the denominator. So instead of saying the 4th root of 256, I could say 256 to the 1/4. Or this one, instead of the 5th root of y, y to the 1/5. So whatever's out here goes in the denominator. Now, on this one, it's already raised to the 3rd power in here. It's x to the 3rd. So I'm not going to change that. That's where that 3 came from, right there. So this 3 is right there. And again, out here is a square root, so it's the denominator. It's 2. If I want to switch it from this way to this way, when I see that I have a fractional exponent, that denominator is what goes right here. Denominator here. Denominator goes here. Now, this one is like this one. This is my denominator, so it goes here. This part here, the squared part, goes inside. So I can do these. They don't just have to be with a 1 on the top. If I already have something in there, like a 5, that goes in the numerator. The 4 goes in the denominator. The 5, that 5 here, means I have this 5 in here, 4 to the 5th. That 4 goes out there. Squared goes up here in the numerator. The 3 goes in the denominator. So the way to solve these without using a calculator is to kind of break them down using that thought process. So 9 to the 3/2. Well, I know that I could write this, right, as this is the same thing as saying 9 to the 3/2 is the same thing as saying 9 to the 3rd, the square root of 9 to the 3rd. But 9 to the 3rd gets really big. So yes, I could do 9 to the 3rd and try to take the square root, but I only really know my square roots up to about maybe 13 squared. 9 cubed is going to be big, right? 9 squared is 81, then 81 times 9. So if I want to do this without a calculator, I can also think about 3/2 is the same thing as 1/2 times 3. That's how I get 3/2, 1/2 times 3. So I could do 9 to the 1/2 and then to the 3rd power. And what that means now is I have a smaller number to deal with, because 9 to the 1/2 we just learned is the square root of 9. Well, the square root of 9 is 3. And now 3 to the 3rd, those are much smaller numbers. 3 times 3 times 3 is 27. So that's another way to break these down. Same thing with here. If I square 125 and then try to take the cube root, that's a really big number. But if I take the cube root of 25 first and then square it, well, the cube root of 25 is 5. 5 squared is 25. That's a much smaller number, much easier to deal with. Same thing here. The square root of 25 is 5, and then I can do 5 cubed. The square root of 16 is 4, and then raising it to the 5th power is still kind of a big number. And negative exponents just means I flip it, right? Negative, I'm not allowed to have negative exponents, so I just switch it. So this moves down to the denominator, and I put a 1 on top, and it becomes a positive 2/5 when I move it. And then I can take the 5th root of 32 and square it. Or this one. I move this down to the bottom, take the cube root of 64 and square it.